Good morning, everybody. Again, thank you all for coming. It's really early in the morning. It's my first time teaching like an 8:30 session, so I'm also trying hard, to wake up early and attend. Anyway, we made it. Today, basically, like last week, I already spoke about certain issues yesterday. You can definitely feel free to just go back to the recording from yesterday. It's not just for session end. You're more than welcome to attend if you want to. So yesterday we spoke about this. There was only one Google Doc question which I addressed, which is pretty straightforward. You can definitely take a look if you want to. And there was one follow-up question regarding how we can analyze the loop counter patterns, which I also did. And then we spoke about the climb recursive method. I think that one was pretty much fun. It's a similar idea to the group sum method that we did last week, like last Wednesday. If you guys get a chance to take a look, you will actually find that the solution, the structure of the solution is not exactly the same because one uses array, the other one doesn't. But the idea behind about passing the recursive call for some strictly smaller problem, the idea is really the same, right? So that's something I can recap very briefly. And today, what I want to really do for you guys, specifically is to extend the problem itself and then to make it more challenging, and then I'll give you the idea about the solution. The solution turns out to be not that much extension, only a few lines of code, and you will be amazed just by adding a few lines of code to the original recursive solution to the climb. You can really retrieve all the climbing strategies as a hash set. That's something we'll see today. Right? But of course, before that, I would like to make some announcement. I want to give you guys some chance to still ask questions related to lecture if you have any, right? And if we can manage to finish early, I'll let you go early. If we have to go until the end of the 90 minutes, we'll do that. We'll see. Right, so let's now first of all start with some announcement for this week. Okay, quickly. Your lecture number 3 was announced, and let me emphasize that was released yesterday, Wednesday. So this is the first lecture where we start to introduce about the singly linked list as opposed to arrays. I think overall I will spend 2 weeks talking about this particular subjects. The subject itself is actually very interesting. It's a very popular topic when people ask you technical question in the coding interview. Let me give you some tease about what the topic is about. If you talk about linked list, the idea about it is incredibly simple. Basically, you just got a chain of connected nodes. Each node basically got 2 parts. One is about some pointer to some data objects. And the other pointer is really a pointer pointing to the next chain of nodes, for example, like that. And that's it. That's about the definition for the linked node. However, the number of problems that we may ask you to solve, either during the test or during the exam or the assignment, is simply unbounded. There are simply so many possible ways we can ask you a question about it. So what I plan to do in the lecture, I will cover the basic operations for the singly linked list for this week. And then for week number 4, I will go on to talk about the remaining operation for singly linked list, and also another variant called doubly linked list. I'll cover all the basics first in the lecture. Make sure you understand the basics completely. And then during the Q&A and also in your programming assignment number 1, I'll give you slightly more challenging problem to solve. Hopefully that'll give you more motivation. So I think you'll be your best interest to really go beyond what you were given in this course to solve. And then you really want to just Google for linked list questions. There are many resources on the web as well. You can definitely go to do some extra ones. I'll definitely do some extra ones with you in the Q&A, but it's limited, right? All right, so that's about week number 3 lecture. And your assignment number 1 will be released next Monday, meaning that between now and next, I will try to release by the end of next Monday, but I'll give you 2 weeks to do the assignment. You definitely got enough time, so you don't have to worry. And between now and also maybe early Monday, it will be your best interest to really study the lecture for week number 3. If you can finish that, that'll be awesome. That means you're pretty much ready to really tackle the challenging problem for programming assignment number 1, right? That'll be my advice. Of course, if you really prefer to really study the lecture and do the assignment at the same time, that's okay. It's your call, but that's my advice. You may just want to struggle through the lecture material, because I believe most of the students in 2011, this might be your first time learning about linked list. I don't think your instructor in 2030 would have covered linked list. All right, and let me now try to address something that's also very important, which is about how we're going to do beyond February 14th in terms of the in-person learning. Okay, I haven't really 100% confirmed the plan, but I think it's pretty much there, right? But you wouldn't be too surprised to you when I write to you to confirm. So I will try to confirm with section N and section Z, the entire 2 sections in writing sometime next week, I hope, but definitely before February 14th. But I can tell you pretty much the direction I'm heading to. Okay. First of all, let's talk about what's really confirmed. Okay. What will stay unchanged. So we will still do the pre-recorded lectures for every week, so you don't have to worry about attending the live lectures. Okay. So but for the lecture materials, I will still keep the flexibility for all of you. So I'll still release them on Wednesday, and you got up to a week to really study the lecture at your own pace, and then to rewind the video, whatever you like, and then you will get a corresponding Q&A to clarify your doubts. Right? That's something wouldn't change. And for the weekly Q&A, and also for my office hour, I would suggest that we keep to the Zoom. And I said in the first instance, I think the majority of the people who actually participated in the survey, right? Remember we did some polling. Of course, not really everybody in the class actually responded, but I definitely can see the trend about like what the majority might prefer. I think for these two resources are mainly to help you. So I can go with what the majority really prefer. So I think I will keep the Q&A and also office hour to be over Zoom. But maybe sometime, maybe after a few weeks, after the reading week, I'll try to decide, if you guys really would like to have some hours being in person, I can definitely consider and then implement it. That's something we can do. But at least for now, in the first instance, it's going to be Zoom. If it has to be turned into person partially, I'll let you know explicitly. So you can definitely come to campus if you want to maybe see me in person. And for your tests, both the written tests and also the programming tests, again, in the first instance, I will keep them online for the first instance. Okay, just make sure I'm consistent here. Yeah, in the first instance, I'll still keep them online. However, there's something I would like to mention to you. So I had some email exchanges with our undergraduate director, and of course, they got a message from maybe the vice dean in Lausanne. Maybe they actually got a message from the authority in the university. So since section N and section Z, both sections are actually designed as in-person, like a delivery. So meaning that we definitely can actually arrange tests or some sessions, to be live and also in person. We definitely can do that. But I think for the first instance, I would like to keep them online because you guys are used to it, and also the majority actually prefer. However, it is possible. So that's why I want to emphasize it is possible. For some of them, they may be in person. In which case I will decide, and I'll let you know at least 1 week in advance. For example, maybe I will decide that for our second written test, I want to make it in person. So that means every one of you will actually need to come to campus to take it, maybe in the scheduled lecture hall. That's something we're gonna do. But for the first instance, I'll keep it online. But if I change the formats, I'll let you know. You'll definitely get enough time to get prepared, right? And from the university's point of view, I'm not sure if you guys went to the virtual town hall last Friday. So I think that there was a similar question that was asked by the student, asking if they really cannot really come to the campus for non-medical reason. Either they don't feel comfortable, or don't feel comfortable about coming to the campus, or they're simply not in the country, or they don't want to commute. The university said you should either switch to a remote section, like a section M in our case, or you have to drop out, right? That's what the university said. I'm just carrying the message over here. So I think for you guys, I want to keep the maximum flexibility. However, you want to make sure that I may just call you in for in-person assessment. It is possible, all right? And one thing that's for sure to be in person will be the exam, right? That's something we cannot even negotiate. That's something that's required by the departments. I'm pretty sure they're required by the Lausanne. So for your in-person exam, it's going to be scheduled by the registrar office during the exam period, sometime in April. So you want to make sure you don't make any travel commitments, pretty much like before the pandemic, if you already attended the school. You want to make sure you make no big commitments during the exam period. So the exam can be scheduled at any time, even during the weekend, right? That's something beyond my control. As soon as I know when the exam will be, I'll share with everybody, right? So we have to come back to campus to take the exam, right? All right, guys. Do you guys got any questions related to the administrative issues? Please. Anyone? In case I wasn't very clear. Go ahead.
Yeah. So for section Z, our test time would be Thursday or Tuesdays at 8:30 in the morning.
Yeah. Yeah.
So
Okay.
we
Good.
still have the chance on Wednesday,
that's something I will make clear about the test time, but let me just address that quickly. It's consistent with what I said in the syllabus section. Let me just emphasize that. Let me actually. I might just need to. Sorry, I might just need to open the semester calendar as well. So let's be precise. There we go. Okay. Right. So let's say, for example, let's say for your written test number 1, it's scheduled to be on February 14th and 15th, right? These 2 days, right? So if you go back to the weekly schedule over here, you can see either 14th or 15th. So for section N, students can, for both sections, either section N or section Z, you're more than welcome to either attend this one over here if you can make it, or you can take in this one, only one, exactly one, but not both. So John, is it clear?
Yeah, does this still stay if we go in person?
The written test 1 over here, I will give you the preparation guide around this time, at least a week in advance, and then I'll confirm about its formats. Because 14th is a bit tricky, because 14th is actually the first day when we return back in person. So, but I would say I'm more inclined to make this first one maybe online. I'm more inclined, but I'll definitely confirm at least 1 week in advance, so you definitely know it for certain.
And like for future tests as well, do we still have like the option to choose any of the 2 sessions to do the test?
Yeah. So yeah.
Okay.
So John, let me put it this way. I thought about originally, I should say section N can only take it here, and section Z can only take it over here, right? That's pretty much that will for sure works because that's your officially enrolled section. But I just wanted to give more flexibility. For example, if you're in section Z, but somehow you just prefer to take it earlier to get it out of the way, you can definitely take it here as well, right?
Yeah, perfect.
Yeah, that's my intention. Yeah. All right, very good. All right, guys, any other questions? Anything just related to the course, right? Yeah, I can imagine. Well, I think I was a student before many years ago, so I can imagine that it will be somehow difficult to really keep track, right? When you're given so much flexibility, especially, let me just go here. If I go to the semester calendar, right, you can see our first assignment is only going to be released on Monday. Of course, that will give you a little bit of time to do, but I think your very first more serious assessment will be on February, right? So that means some people may decide to procrastinate their week number 1 to week number 4 lecture maybe until even this week, and then start watching that. Too bad. I think that'll be difficult for them to digest the contents. So I would say if you really are behind in just for 1 week, it would be your best interest to really catch up, to make sure you really stay on top of things. I think things will just get more and more challenging to grasp, which is the nature of this course. Right, that'll be my advice. Okay, I'll pause for one more moment to see if you guys got any more questions related to the administrative issues. But once more, I'm going to confirm about this part over here in writing, hopefully by the end of next week, right? I'll confirm with everybody, right? But that's pretty much the trend. That's pretty much the preliminary formats.
Professor?
Yes, please.
Yes, hi. I just want to ask, I don't know if it's been asked, but would the test, like the programming test, written test after the first one, would be in person or would be online?
Okay, so that's okay. As I said over here, I think it falls into the more like a to be determined category. Okay,
Oh,
so
okay.
I know it sounds a bit uncertain, but I can tell. How about okay? It should be fair to say this, including your written test number 1, because written test 1 somehow, technically speaking, it it happens after we officially went back in person, right? So think about for all your 1, 2, 3, and 4. For all the tests over here, let's say they will be run online in the first instance, as for now. However, don't be too surprised if whenever I release the preparation guide for your test, usually it should be at least 1 week in advance. I might just say, okay, guys, for this particular test, let's now come back to campus to take it. It's possible. I'll reserve that option. But in principle, they should be online, but it might be changed. But it will be confirmed at least 1 week before the test occur. So you definitely get enough time to settle down, to get prepared mentally and physically.
Okay. So since our section is morning 8:30, and
Yeah, I know. Yes. You know what? It's yeah, you're right. It's if some, let's say hypothetically, if somehow we decided for a particular test it's should be in person, in that case we may have to go a little bit more like before the pandemic, right? So you can only attend the test in your section. In that case, you're right. That'll be 8:30. Yes.
Okay.
That's a
Yeah,
bit,
'cause
yeah. Of course, I know there are many factors, not just covert. I mean, there might be factors like a weather, and also it's just early. I mean, even for myself, if I need to make it to 8:30, I need to wake up around 6 a.m. to get prepared.
yeah.
But anyway, so it's let's see what happens. But I would say that's why I said in the first instance, I would like to have all of them to be online, which I think we can also assess your knowledge properly, I believe. But if there's any factors that might have to be added in that case, I might change the formats, just to let you know. Yeah.
Okay.
Awesome.
Yeah.
Right. But you guys can expect to hear back from me about the written test number 1, about the 4th of February, basically next Friday. You can expect it. And in that case, I'll definitely confirm. Yeah, I cannot. I wouldn't do the following. I wouldn't say only 2 days before the test. I say, okay, guys, I said we're gonna take it online, but now let's take it in person. No, I wouldn't do that. If I confirm already about a week in advance in the preparation guide that we're gonna do it one way, I'm not gonna switch no matter what. Okay, that's not fair, right? Alrighty. All right, so seems like you guys are okay, but feel free to reach out to me if you got any confusion or concern. I hope that might be the best, based on people's preference. But at the same time, I think we can run the course without sacrificing much, especially for the lecture contents. But I think, of course, the biggest catch, guys, is you don't really have like a physical live lecture to attend. Of course, that's the nature of online learning. You have to make sure you actually catch up and also stay on top of the study steadily. That's the thing, right? If you can do that, then I think everything is really to your advantage. All right. All right, so guys, I think the only thing, so that's it for the announcement. As I said, I want to do some follow-up to yesterday about Sarah's request about doing some call stack tracing, just to give you guys some idea. I'll do that. And also, we'll solve this challenging question together. I'll give you some intuition, and then I will program that in Java, and then I will trace it quickly. Right? That'll be the plan. But before that, I would like to open the floor to see if you guys got any questions related to the lectures. I think that's really the most important thing to clarify first before we solve some extra things. Right? I will pause a little bit right now. So I only checked the Google Doc. The last time I checked it was about 10 p.m. last night. There wasn't any new questions added. So that means everything has been addressed yesterday. But if you got any new questions here, you can feel free to ask me now. I'll handle them first, and then we'll move on to the extra stuff. Right. You guys can feel free to speak up if you got any questions, or put on the chat if you prefer. Yeah, maybe pause for 1 minute, so you got enough time to ask the question. Yes.
Hello?
Yes.
Hi. I had a question from I believe this is week 3, right? So
week
number
2? You mean the lecture? Lecture should be week number 2.
Yeah, the lecture is the base data structures array versus linked.
Oh yes, sure.
Yeah.
Okay, let me go there. Which slide?
slide number 6.
Number 6. Okay, let me just go there. Yes, what about it?
Yeah, so I understood how this whole like the for loop everything works, but my only problem was at the end how you calculated the big O notation.
You mean like over here?
Yeah, like the big, like you found the big O is n squared, but I want to know how did you find it? Like I was confused in that.
Okay, sure. I can just highlight about the steps you should really take. But of course, you can definitely find the details again, maybe from the lecture as well. Let me just do it now quickly, and then you can definitely find more details back in the lecture. Yeah, let's do that. Sure. Of course, it will be important. I think at some point, either in the test or in the exam, you will be given some mysterious method, for which you don't have to know exactly how it works, but you have to know how to calculate its running time. That will be very important. All right, let's now do it. Good. Okay, let's now highlight the loop over here. You can see, let's say there's an outer loop over here, and this is the inner loop over here. All right, and before I go on to talk about the number of iterations, let's now talk about other things, right? You can see just for this line over here, it's part of the body of the outer loop. So this is just constant. Okay? And then if you look at just this line over here, it's part of the body of the inner loop. And this one just about array indexing, relational operation, array indexing, assignments. So that's also big O of 1. So our purpose now is only to approximate the running time. We're not calculating the precise number of primitive operations. You can do that as an extra exercise if you wish. Okay. And then this part over here is also part of the body of the loop for the outer loop, right? You can definitely tell from the indentation I made, right? This one here should be also big O of 1, array indexing, variable assignments, array indexing, etc. Big O of 1, right? Basically, for every iteration, for every iteration of the inner loop, it is going to execute something that is constant. Number 1. Number 2, for every iteration of the outer loop over here, it's going to definitely execute the inner loop, and that one there is going to dominate the performance because everything else, like this line over here and this block over here, are simply just constant. So this part here, once we know its performance, is going to dominate. So that's the two things you want to pay attention to first. Do you follow so far?
Yeah.
Very good. Okay, let's now talk about the iterations, right? And this one indeed is a trickier case because if you look at the initial value, so if you look at the outer loop, I will be initialized to be 0, and then it will go up to and including n minus 2, right? So we are talking about from 0 up to n minus 2. So we'll talk about this particular interval to n minus 2, right? And we spoke about how you can calculate like how many numbers are in this interval, which will correspond to how many iterations we got. So from 0 to n minus 2, right? So you can simply say the upper bound minus the lower bound plus 1. So that's a formula. Okay, so it's going to be n minus 2 minus 0 plus 1, which will be n minus 1. So we're talking about n minus 1 iterations for the outer loops. So far, so good?
Yeah.
Very good. Okay. Now, for the inner loop, that'll be the tricky one. Because the initial value of j is not just a constant. It somehow depends on what the current value is for I, the outer loop. So that's why you need a little bit more numeration to really clarify what's going on. So what we want to do is to do something very similar to what I did in the lecture. Okay, It's going to be starting from I, and we'll go all the way up to and including n minus 1, right? That's what's going to happen over here. Okay, let's see. So let's now do the analysis. We know that for the outer loop, it's going to be I. The value is going to be 0, 1, and 2, all the way to n minus 1. Okay, so we know that over here, for the outer loop, we actually got n minus 1 iterations. And then for every iteration of the outer loop, I is going to take certain value, which will trigger another series of iterations of the inner loop. Let's now figure that out exactly. So you can see J over here, when I is actually equal to 0, J is going to start from 0, and then 1, because it's going to be J plus plus, right? J 0, 1, 2, all the way to n minus 1. So far so good. And then for this part alone, how many iterations do we have? You can tell me. How many iterations do we have for the inner loop when I is equal to 0?
We would have n minus 1 iterations, right?
It will be not, well, to be more precise, it should be n minus 1 minus 0 plus 1, right? We start from 0, right? So be careful. You got to be precise, okay? So that should be n iterations. This simply means for the very first iteration of the outer loop, it will trigger n iterations of the inner loop. That's basically what we are saying. And then for every iteration of the inner loop, it's only going to take constant amount of time to really to calculate, to really execute, right? All right, let's now go further. So let's now talk about when I is equal to 1. In that case, J is going to be starting from I, which will be 1. So it's going to be 1 and 2 and all the way to n minus 1. And for this one over here, it's going to be strictly one less iteration, right? So that was going to be n minus 1 iterations. Okay. Yeah, so if you can already see the pattern, you can simply stop here and go to the last one. Go to the last value for I. If you cannot see it, you can just do one more. Let's just do one more, okay, for completeness. When I is equal to 2, over here, J is going to be 2 and then 3 and then all the way to n minus 1. And that one will be, not surprisingly, just be one iteration less again. So that'll be n minus 2 iterations, right? And of course, you can also double check the answer by simply calculating what's the size of the interval from 2 to n minus 1 by using the formula I mentioned in the lecture. Good. Very good. And then we're gonna go on until the very last value. In the very last iteration for the for loop over here, the outer loop, I is going to take the value of n minus 2. When it gets to n minus 1, like a 1 larger, it's going to evaluate to false. It will exit from the loop. So there'll be no more iteration. So this will be the last. So that means it's simply going to start with J being equal to n minus 1. And then you can see n minus 1 is already equal to n minus 1, the largest value we should take for the loop counter. So we're done. So only one iteration.
Okay. Oh.
Okay, very good. And then I'm going to conclude, and then I'll take your question. So basically, what we should do is for every iteration over here. Sorry, let me say it again. For every iteration of the outer loop, we're going to trigger this many iterations, and it might be different depending on what the value is for the I. So that's why we're going to write them out explicitly and then add them up. That's why. And for every iteration of the inner loop over here, it's going to be just constant over here, right? So you can think about what we need to do is, let's now do this part over here, the purple. Let's do this, 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 and this. It's going to be simply n plus n minus 1 plus all the way to 1. And then we know that for every iteration, it's going to be simply big of 1. If you want to, that's what you got to write. But 1 multiplied by has no effects. And this part over here is simply an arithmetic sequence. So you're going to do the beginning plus the end multiplied by how many terms we have. You basically go from 1 to n. So n terms. And divided by 2. That one there is basically big O of n squared. Because you can see over here, if you do the math, n squared plus n. So n squared is already the highest term. So you can say big O of n squared.
Okay.
Yeah. So I think in the lecture itself, you can maybe fast forward to maybe about this part. I try to go a little bit more detail about how to also consider this part over here and this part here. But as I said, I think this part here already dominates the running time. So if there's only a multiple choice question, you don't really need to go this detail. Once you get this n squared, you know this is n squared. On the other hand, if it was an essay question, in that case, you will have to show how this, and this have been taken into consideration. That's something you can also refer back to the lecture. You'll see more detail.
Okay. Yeah. Makes sense.
Okay, I hope that makes sense to you.
Yeah.
Awesome.
Thank you.
No problem. Yeah. Guys, I think that is a very important question over here, right? And if you also refer back to the Q&A from last Thursday, I think what we did was we actually tried to do when you got a nested loop, and then how you can calculate the number of primitive operations. That's something you want to review as well. Make sure you can do it. All right. I'm not exactly sure if I would have a very detailed, like an essay type of question for your written test number 1 or 2, but definitely for the exam. You definitely want to get prepared in advance, right? All right. Any other questions related to your lecture? Please. I don't think the recursion problem itself will take too long because I think it's challenging, but I think the solution itself is not to add so many lines of code. I'll definitely give you the solution. I will highlight what you should really pay attention to, and the rest will be really up to you to really spend some time thinking about how that recursion work. I'll definitely give you some guidance. Right? But the more fundamental thing is to understand the lecture. That's for sure. Don't lose the basics.
Sorry, just a quick question.
Yes.
For I, we go from 0 to n-2, right? But that still won't really affect the value. No.
You mean
because we have n-1 iterations.
You mean here?
No, do like below. We underline it in pink.
You mean sorry, you mean John, which part are you talking about? Are you talking about this part?
Below, where you
below?
like in green.
You mean this part?
Yeah, but yeah, because we have n-1 iterations, so then
yes.
I would have to go from 0 to n-2.
Yes.
Right? Just the value of I. Not
the value of I, yes. Yes. So yeah, exactly. So because J will actually start to be I and then go all the way to n-1. So that's why either start with 0 or it start with 1 or it start with 2. That's the pattern.
Yeah, okay. So it's just the last value should not be n.
Yeah. Oh, the last value. You know, the last value. It might be the most confusing part. Seriously, you know, when I first time taught this one, I found it confusing too myself. I never found it confusing when I was looking at that by myself. Anyway, this one here is not. It's not n-1. By the way, why is that 1? So you gotta understand this very clearly. This n-1 simply means when I is equal to n-1, meaning that it's the last iteration for the outer loop. In that case, when we execute the inner loop, J is going to take the value of I, which is n-1. And when J is equal to n-1, we know that it's going to be the very first and last iteration at the same time. Because once n-1 gets incremented to n, in that case, n less than or equal to n-1 is going to be false. So we don't go any further iteration. So when J is equal to n-1, that's the only iteration you will go when the outer loop got the loop counter value I being equal to n-1. Does that clarify?
Isn't the lowest value you can go is n-2?
No, this is less than or equal to.
For the I.
For the I, for J.
No, for I, because we say that the lowest value is n-1. Is it n-2, you know?
It's n-2. Yeah. Oh, John, wow, you're so good. Spot on. Yeah, sure.
But that doesn't really affect the actual problem.
No, it wouldn't affect. But you know, John, appreciate it. I think it's important to be right. You know, if I were to answer this as a multiple choice question, then most likely I'll get it right. It'll be n squared. But if I answer an essay question, I will lose maybe 20%. Right? I appreciate it. Good. I think John's observation is spot on. The last value here should be n-2. I didn't notice that. Okay, n-2. I agree. In that case, you're right. It's going. Let me just do it again. Just this part. Okay. In this part here, it's going to take the value of n-2, right? n-2, and also can go all the way up to n-1. So it's going to be n-2 and also n-1. Yes, and then so for the last iteration of the outer loop, it's going to trigger 2 iterations of the inner loop. So we just have to modify the sequence over here slightly. Rather than 2 over here, it's actually going to rather than 1 is going to be 2 over here, and then it's going to be n plus 2, right? N plus 2, the n over here and 2 over here, and then rather than n turns, it's going to be n minus 1 turn, right? Because it goes from n to 2, right? And divided by 2, it's still going to be n squared for sure. Yes. So John, hopefully that addressed your concern, your confusion.
Yeah, I understand. Thank you.
Yeah, it's spot on. I think that's important. Yeah, absolutely. All right. All right, so here I got some question over here. For the written test, would any of those practice recursion problems be asked? Or will there be just the one we learned in the weekly lecture? Okay. I would say I will make it clear about the coverage of the your written test number 1, since you asked for your written test 1 or 2. I'll be very precise about what's going to be covered in terms of topic. For example, if written test number 1 actually covers recursion, I'm not too sure if I can get there before your written test number 1, but let's say if I can get there, then I'm in that case, yes, you have to make sure you understand the problems that we went over in the Q&A. In some way, that's like additional practice for you. So of course, when I say we'll test you about recursion, it's true for every course, right? You have to make sure you understand not just the concept we cover in the lecture. You should also be able to solve something that might be beyond the lecture. Of course, that's still the same topic. Yeah. So for your written test 1, let's say, which is coming soon at some point, I will be clear about the topics that's being covered. If that one covers recursion, in that case, yes, you will have to make sure you understand the problems for what we cover in the Q&A. All right. All right, guys, any more questions about lectures? Any more before I get on to recursion? Everybody is okay? Okay. Yeah, I think so far you learned about 2 sorting algorithms. One is selection sort, the other one is insertion sort. I think that they are both conceptually simple, but to really get into work precisely in Java, it's not that trivial, as you can see from the code, especially insertion sort, right? So I would say, yeah, so I think you definitely want to make sure you know, like what I said, before you graduate with your degree, you should know at least 5 sorting algorithms. And we're going to learn about 5 exactly in this semester. So the next 2 we're going to learn when we cover recursion, maybe around week number 5 or week number 6, not too sure. But we're going to cover another 2 sorting algorithm. One is called merge sort. Merge sort. The other one is called quick sort. So these 2, they're both very fun to learn. They're both recursive. We'll see once we get there. So that'll make it 4. All right. So guys, no more questions related to lectures? No? Would it be okay if I move on to recursion? Well, so up to this point, you should think about, good, thank you. Thank you for confirming. So you can think about up to now, we haven't really started officially in this course to cover recursion. So the reason that I want to cover some extra problems together with you guys, really just to give you more exposure to recursion. To be honest with you, it's really difficult to cover, to really let you learn recursion perfectly just by the lecture. It's difficult. You really have to solve as many problems as possible. That's my intention. So we solve as many as we can, at least in the Q&A, hopefully get you motivated so you can really go beyond the lecture, go beyond this course, and then to find other resources for yourself to learn about recursion, right? Just you just keep solving problems. That's the only way to really click on yourself. All right, good. Let's now talk about recursion, right? But I would like to talk about one thing, which is also very relevant. So yesterday, when I spoke about the solution to the climb, I can highlight it a little bit, but I wouldn't be able to maybe go from scratch. So for you guys who are interested about this easier problem, you can definitely look at the watch the Q&A from yesterday, right? It's there already. Right, so just to give you some idea, yesterday we spoke about how you can trace the recursive call, right? So if you want to say, I want to climb the staircase of 4 stairs height, And each time I climb, I can only climb up to 2 stairs, either 1 or 2, basically. So that's why whenever the recursion tree branches out, it's going to be either I climb for 1 stair or I climb for maybe 2 steps, either 1 step or 2 steps, right? So each branch is going to be 1 or 2, and also 1 or 2, and etc. That's going to be the outline for the recursion tree. All right, that's something I assume you would know when you actually listen to this part. But if you don't know, that's okay. Catch up with the recording from yesterday. So what I want to do now briefly is to, it's more like I think Sarah asked me this question yesterday. We learned about how to trace the recursion using the tree structure, which I believe at this level, this will be the most effective way to really learn it without losing without getting lost. However, exactly how the tree over here is being built or is being implemented at the runtime is actually exactly using a call stack. If you go back to maybe back to 2030, when your instructor, who may or may not be me, but when we actually cover, let's say factorial, or we cover Fibonacci number. So the way we trace the recursion is by using the call stack, right? But once you go to more complicated example, using a call stack is no longer effective, at least for humans. You can simply just get lost about what's going on. But if you use a tree, it's much easier for you to keep track. So what I want to do now is to show you about the idea of the correspondence between the call stack over here and also the tree. That's something I want to show you, right? So think about this tree is eventually what's going to be built by the recursion tracing. But on its way to the ultimate completion, you have to use a call stack to keep track, right? I want to give you some idea, okay? And I'm actually going to number. So this is something I assume. We start with the climb for 2. That's the initial problem. And then we're going to branch out differently, right? Like this, etc., right? Now I'm going to number the nodes in a particular way, right? You don't need to know about exactly how to do this kind of numbering systematically. You'll learn that when you get to the after the reading week when we talk about tree. It's called something called post-order traversal. Okay, let me write it down. You can keep this. You can make a note of this, and then later on when we talk about post-order traversal, you can come back. That will make sense to you. Okay, post-order traversal, right? Now, I'm not going to talk about exact detail. I'm just going to number the nodes, okay? So let me use, how about green over here? I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. So here I got 15 nodes in total, okay? Somehow the number I put over here correspond to the order in which these recursive call will be pushed into the stack, somehow. All right, let me give you some idea, and I'll do a part of it. You can definitely try to complete the exercise, okay? What's happening is here. We start with the climb for 2, and we know that it is actually not a base case, right? So that means we have to go to the else branch over here, and then we have to run a loop, and then the first iteration will be we're going to try it out when I is equal to 1, right? And then we're going to do another recursive call. But we're definitely going to start with, so I'm going to use the green over here to say I'm pushing something into the stack, and pop when we remove it, right? I'm gonna do a few, and I will leave the rest to you. Maybe especially Sarah, if you're interested in completing the exercise, but for others as well. Right, so I'm gonna say, first of all, we start with pushing this first call into the stack, right? So I'll just say 1 over here. Okay, and then after that, we're actually going to this one here, climb for 2, is going to run a loop. And for the very first iteration, I will be equal to 1. In that case, we're actually going to call this climb over here, 3, 2, right? It's 4 minus 1, which will be 3, right? 4 minus 1. So this will be the first iteration. And now, one thing to really note is the second iteration is basically pending until we can actually finish this entire branch of the tree, right? So that's something I want to make a note as well. So that will be the essence about understanding what's going on over here. So you can think about this part over here. This part over here. Okay, so this is the first iteration. Let me just try to draw a little bit better. I want to draw a triangle. Okay, this part here. So this is the first iteration. And this part over here is the second iteration. Oh, actually, sorry, let me do it again. Beg your pardon. That should be higher. So this one over here is going to call this for loop. And then we know that it's going to be I less than or equal to 2. So there will be 2 iterations. So this part over here is the first iteration. And this part over here is the second iteration. And while we are constructing the tree for the first iteration, the second one is simply pending. We're not going to do anything until we are done with this part, right? That's really important. That's why when you see the node over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we are not, once we are done with all these 10 calls, we're going to go on to do the second iteration, right? That's something I want to annotate quickly. So for this part over here, let me try to, how about just highlight over here? So this part over here, okay, so this will be the first iteration. And this part over here on the right, it will be the second iteration. Okay, this part here will be the second iteration. Okay, let's see. And I'm going to look at this call over here for the first iteration. It's going to be climb 3.2. And climb 3.2 is also going to go to the else part over here. So that means we're going to push that also onto the stack 2, right? And then we are facing the similar situation. Before we can finish the first iteration over here for climb 3.2, this part over here is simply will just be pending. Right? So that's really what you want to see for every recursive call. You always have to make sure you do the first iteration before you can get to the second one. So that's really what we're doing over here, right? This loop over here. So this will be the first iteration. And this will be the second iteration. So now we're going to move on to this particular part over here, right? So now for number 2, it's going to be they'll be placed on the stack. And then we're going to go for number 3. And for number 3, and similarly, we got either first iteration or second iteration, similar idea. And then we're going to go for number 4. And then we go for number 5. So now we're basically reaching a base case over here at the bottom, right? So far what we have got is we basically climb, and climb. So these are the 1, 2, 3, 4, 5 different calls we push onto the stack without removing anything just yet. But now we are reaching one case where it's already the base case. That means it's going to return. So once it returns, we're actually going to, let me use a pink over here. We're going to remove it. So number 5 will be removed. That means we go back to number 4. And for number 4, since number 5, which represents the first iteration, has been removed, so now we can go on to the second iteration. In that case, the second iteration will be number 6 over here, right? So we're going to go for number 6. Okay, for number 6 is actually also a base case. So that means we're going to return and then remove it from the stack. So we're going to return and also remove it from the stack. And after that, you can see the stack tells you that the one to really handle will be number 4. And for number 4 specifically, we have already handled number 5 and number 6, both iterations. So number 4 can also return. So when number 4 returns, we're actually going to get rid of it. And the top of the stack will be number 3 over here. Number 3 is asking us to really handle both the first iteration and also the second iteration over here. And the first iteration has been done already because we just got returned from number 4, right? So now we're going to go for number 7 for the second iteration. In that case, we're actually going to actually do number 7 and push that onto the stack, right? Number 7. And number 7 will also return, right? So we push that, and then number 7 will also return, so we remove it, right? It's, again, a little bit tedious, but I think having this tree side by side over here can definitely help you actually trace the call stack, all right? All right, I don't think I should really go too much further, but after removing 7, you can see now, if you go back to the stack, it's going to be number 3. And for number 3 over here, we have done both the first iteration and also the second iteration. So that means we can remove number 3 from the stack, right? So if you remove it from the stack, so that means we're going to handle number 2. And for number 2, we have to go on to this particular branch. And I think this will be to continue with the tracing using call stack by following some similar pattern. Right, for those of you who might be interested, I think this is fundamental, but I think it's also tricky. So my tip would be for you, whenever you want to really trace like a complicated recursive call using a call stack to really see how things can be pushed and also popped, you want to really see what's the corresponding recursion tree, and then just go to the tree and see how you can push and pop, right? Eventually, we're going to learn about something called post-order traversal. That might also help. So Sarah, does it somehow help? Maybe? All right, good. So I can say for exercise, if you're interested, but I think that's pretty important. Complete the tracing from number, it should be from number 8, I can tell you. Number 8, that'll be the next one. Okay, so that'll be for those of you who are interested, but I think that's important. All right, but I think to really design the algorithm, you don't really design the algorithm based on the call stack. It's actually too machine oriented. I think for us as humans, we are creative. We should really focus more on the tree. But that's something you should know as well, right? All right, let's now move on to this. All right, let me now give you guys some brief intro to this question over here. I'll give you some intuition, and then we'll go ahead and program the solution. Okay, we're still talking about the same problem over here. We basically got some staircase of certain heights, right? Let me also clarify the terminology I'm going to use, right? Which I did yesterday, but it may not be bad to repeat. We talk about staircase, and also we talk about steps, and also we talk about climb. All right. The idea will be for each staircase, like a problem we are given, it has its heights specified in terms of the how many steps you have. For example, you might say the heights simply got 4 steps in total. And then our strategy will be you want to really do a number of climbs. Each climb can be up to the specified number of steps. For example, if we got 2 over here, that means, for example, for the first climb, we only take 1 step. For the second climb, we got 1 step, and etc. But for this one here, you can see the first climb, we got more steps, like a 2. And for the second climb, we got 2 steps as well. So the idea about the return value over here is we want to return a set of climbs, right? And each array list of climbs over here is like a strategy for finishing climbing the staircase until its top, right? Either 1, 1, 1, 1 over here. On the other hand, for example, if you look at, let's say 1, 2, 2, this would not be not a valid strategy, right? Because if you did it, 1 plus 2 plus 2 is going to be 5. So that will go beyond the staircase, right? It's not valid. We want to collect all the possible and valid strategies for climbing this particular stair, given that you can only take no more than n steps for each climb, right? So that's a problem. All right. And the example over here is similar the same problem basically from yesterday, but now given 4 and 2. A staircase of 4 steps, and also each climb can be up to 2 steps. So now this will be one strategy over here. You simply take 1, 2, 3, 4, 4 climbs. Each one of them will be 1 step. Or it can be solution number 2. It can be three climbs. The first two, one step. The third climb, 2 steps, and etc. We got 5 different solutions. You want to make sure you include all the possible solutions in the return hash set over here, right? And I think at least for me, I cover array list in 2030. But I think for the hash set, you can definitely take a look at the API, the Java API for that. It's also a very handy Java library class. The way to use it is very similar to the array list. The only difference is, you know that mathematically, the difference between a list versus a set. So the difference is that for the set, there's no ordering, which means the way we actually organize the strategy over here, there's no order. So it doesn't really matter if this one appears maybe before this or after this, doesn't matter, right? So that's what a set is. But for the array list over here, the order does matter. So for example, for this particular list, the climb is, that's not a good example. For this climb over here, this strategy, the first climb must be 1, and the second climb must be 1, and the third one must be 2, right? If you say 2, 1, 1, it's simply not the same as this one here, right? So that's why we have a hash set of array list. That's why. All right, and the input parameters would just be the same as before. We got the heights, and also we got the maximum number of steps you can take for each climb. All right, and the assumptions are the same as before, and that's the input output, right? I would like to start by asking, do you guys got any question just related to the problem itself? Is there any part that's not clear to you, what the problem is asking you to solve? Let's get it straight first, before I give you some intuition and our program. Anyone? I'll pause for a moment in case you're still thinking. So at this point, make sure you understand what the problem is asking, right? It's really important, so that when I get to the intuition of the design and also the actual Java code, you wouldn't get so lost. Of course, beyond this Q&A, you definitely need to spend time to really study this example. It does take time to really understand it. Excuse me. So everybody's clear about what the problem is? Okay, I assume that's the case. And let me now give you a little bit intuition over here. So this is the tracing tree for calling climb for 2. And this is actually from yesterday's Q&A. Let me just make it clear, explicit for you. So this was the easier version of the problem over here, where all we want to know is how many possible strategies are there to really climb the staircase. But now we have extended the problem to be harder. We want to know not only that how many, but exactly what are those strategies, right? But I'm gonna reuse the tracing tree from yesterday, so that'll be much easier for me to tell you what the extension will be. All right, over here. Okay, we basically need 2 data structures to really keep track conceptually, right? And you will be amazed the way I give you the intuition. Hopefully that makes sense. It will be pretty much corresponding to exactly how recursion will occur abstractly. Okay, so we need 2 data structure. One will be the set. Okay, let's see this. Okay, so this will be data structure. So this will be the hash set. And I call it a solution set. It will start to be empty. And then every time when we reach a base case where we know the height is actually 0, that means we have reached, up to this point, we have found a valid solution. And the valid solution being, we simply take 1, and then 1, and then 1, and then 1. So the valid solution will be an array list that contains 1, 1, 1, 1. And then once we get to this point, we have to construct the array list and then add it into the solution set. So whenever you return, you have to make a decision about whether or not you want to actually add the current solution so far into the hash set. Of course, in this case over here, in this case, you can see the height has become -1. That means we have already gone beyond the staircase, because so far we got 1, 1, 1, and 2. So 1, 2, 3, 4, 5. So this is not a valid solution, meaning that once we get to this point, we simply don't update the hash set, right? Think about this hash set over here is global. Well, when I say global, it's just conceptually. The way we make it to be shareable, to be shared by all the recursive call, is to do call by value. We simply pass the reference of this solution set between all the recursive call. So you always got a reference to the same hash set. That's something you should really pay attention to as well when I program that, right? But for now, get the concept well. And let's see another case over here. Let's say another one over here. This will be another one here. You can see this one here is going to be 1, 1, and 2. So this will be another valid solution, right? So let me now get to the point here. You can see we got 1 here. We got 1 here. And also we got 2 here, right? So once we get to this particular base case where we know we have found a solution, that means somehow you want to add the array list 1, 1, 2 to the set. You want to add this one here to this set here somehow, right? That's the one case. And another case, as I said before, I'll say a little bit more about this case in just a moment. Another case, let's see here. Because if we got 2 and also 1 and then 2 and then 1 and then 2. This is not a valid solution. You can see 2 plus 1 plus 2 is more than 4. So that's why here is minus 1, right? So this part over here tells you that don't add to the set because this is not a valid solution, right? Let me say a little bit more. When you get to this point, you know that conceptually you should really construct a solution that consists of 1 followed by 1 followed by 2 and add it to the set conceptually. However, programmatically, it would be too late for you to start constructing this list just at this point. It would be more appropriate if you can somehow start to construct the list from this point, assuming that starting from here, you're going to eventually reach the solution. Eventually. But if you don't reach the solution, you can just ignore the solution that has been built so far. So what I would suggest is, what we need is we need to have another auxiliary parameter, which I'll show to you. But let me just put it down. Think about when you first call this client over here, you will have some empty array list to start with. And once you know that currently I'm going to choose 1. So that means when I reach over here, the solution should be updated into 1 over here. Conceptually, you're adding 1 into this, right? And this 1 over here will also be expanded into 1, 1 if you go for this route. It will be extended into 1, 2 if you go for this route, right? And I'll talk about something that's very specific to OOP that you also need to watch out for. So once we get to this point over here, we got to extend by 1. So that means 1 over here followed by 1 over here. So that'll be the list at this particular level. And for this one here, there will be different branch. So that will be 1 over here followed by 2 over here. Right? So there is a very technical detail you have to watch out for as well. Let me point it out to you. And I'll also make sure I highlight how I handle that in the actual solution. If you look at this list over here, maybe use a different color. If you use this list over here, take a look at this one over here, and also this list over here. Conceptually, you know exactly what they are, but programmatically, you want to make sure they don't interfere with each other, meaning that you don't want to make sure they are simply aliases of the same list. You want to make sure this is one array list objects, and this is just another independent array list objects. You want to make sure that's the case. Otherwise, you will get some very funny output, which I can suggest. You can modify the code a little bit to get it wrong, and you will see exactly what happened. All right. So let me make the points over here. So this must be a brand new list, meaning that you're going to create a new list empty to begin with, and then you're going to add in whatever that's in the current solution with and add the current choice into there, right? And this one over here will just be another brand new list. another brand new list. And you're going to do such construction for every level. Okay, another brand new list. Are you guys so far so good? So far okay, conceptually, right? But once I get to the code, you will see every point I have just mentioned, they will be reflected in the Java code, right? Right, so what I'm going to do is going to keep growing this list over here. Let me just complete one branch just for completeness. Let's say we go for this way over here, right? So now if you go further over here, you can see we also want to expand. Actually, let's go for that branch. If you go for this branch over here, right? So that means you want to make a new list. You want to simply make a new list over here, copy over 1 and 1. 1 and 1, and then the 2 is the current choice we're making. So 1, 1, 2. And then, so that will be the list we have got. And because up to this point, we know that this height has become 0, we know that what we have built so far, the solution 1, 1, 2 is a valid one. And that definitely it can be added to the set. So we simply add this list to the set over here. Again, it's really important to make sure every list you're trying to build along the way, they are brand new lists. They simply don't interfere with each other. Otherwise, you simply cannot add the correct things into the set. Right? That's the idea. Any questions or any clarification you may want before I start coding? If you understand so far, I think you're about 80% ready to see the code, right? There might be some minor details which I didn't mention in the Java code, but pretty much I've said almost everything. Everybody's okay? All right. Alrighty. Let's now go on to Java code. And the way I want to start with it is I want to show you really the correspondence from what we said yesterday, right? Okay, no, that's okay. Let's just simply do this. We're going to introduce 2 extra parameters. So one will be the solution set. One will be the hash set over here about all the possible solution. The other one parameter is the list that we're gonna build between recursive call, right? So these are the 2 extra parameters that we need. So I'm not too sure if you can really solve this problem here without a recursive helper method, right? From yesterday, I actually used Mohammed's solution for the group sum, which didn't use any recursive helper method. But for this one, this problem over here, I don't think you will be able to get around without using the recursive helper method by introducing some extra parameters. But if you can manage to do it, share with me. I can share with the class, all right? But let's use my solution for now, all right? So what I will do is I'm gonna need another recursive helper method over here. Okay, let me type it out. It's gonna be private, and then I'm not gonna let it return anything. Okay, you will see why. And for this method here, it's very important to understand call by value. To see how call by value works. Right, of course, call by value was covered in 2030. If you got any confusion or doubts, you can reach out to me during office hour. We can talk about the basics. Okay, let me declare the recursive helper method first. Private void, helper method, and then we're gonna say climb strategies. Okay, let me call that strategies. Right, that'll be the actual method, and then the convention is you can just say helper. Right, just add helper to it. And then we are still going to have the original 2 parameters. We still need them. So they are the original problem we are trying to solve, right? Put them here. But I'm going to need 2 extra parameters. One is the hash set, and the other one is the current solution that we are building, right? So I would say hash set. Every member of the hash set is going to be an array list. And every member of the array list is going to be an integer, right? And then solution set, okay? I'm running out of space, but let me just put it this way. Let me put a new line. Okay, you can see these are the first 2 parameters, and we got a third one followed by, and also array list, integer, and then solution so far. Right? That's about the declaration for the method, right? There's no compilation error. Let me just say it again. The solution set over here versus the solution so far over here are very crucial concept to really make it work. Think about the solution set I declare over there is a single object over here that's going to be updated as we go for the different branches over here. Whenever we got a return, that's actually for the valid solution, we're going to update this particular solution set. And because we're passing the solution set as arguments between recursive call, and because the call by value is going to be the same object that's being that's being manipulated, that's being changed. So it's very efficient solution. The other one is about the solution so far. Think about solution so far start to be empty list, and then it will be updated every time when we try to make a choice about the climbing, right? Either we can climb for step number, either we can climb for one step, or here, either we can climb for one step, or we can climb for 2 steps. In that case, the thing to be added to the current solution and passed to different recursive call will be different, right? So that's really something you want to keep in mind, all right? And let's now, before that, let me now put here, before I forget, how are we supposed to use this recursive helper method? The idea will be we're still going to pass the original problem over here, verbatim, h and n. And we're going to initialize some value for the solution set, and also initialize some value for the solution so far. Initial value is actually rather trivial because to begin with, the set should just be empty. You haven't got any solution so far. And also solution so far, because you haven't made any choices just yet about to climb either 1 step or 2 step. So it should just be empty, right? Pretty much corresponding to the empty list over here. All right. All right, let's now do it. So what I will do is I'm going to say hash set. You know what? Let me just copy this, the same type. Right? Let me just do this. And I'm declaring a local variable, you'll see why. And solution set to return eventually, or you can say result, is equal to new hash set. And it will be up to you if you want to repeat this particular typing information, but Java compiler will be able to figure that out. All right, you can just say this. Implicitly, the compiler can figure out what you really meant to say over here, even though you didn't write it, it's going to be exactly what you declare over here. So every member in the hash set is going to be an array list of integer. All right. All right, I gotta speed up a little bit. Okay, otherwise we cannot finish at 10. All right, so that's the solution set, and eventually we want to return just this particular solution set. Right, so that's the idea. However, in the middle, we're definitely gonna do some updates to the solution set. So that's why we're gonna make a call to this recursive helper method. So if we do that, gonna call that, and for h and n, we're going to reuse verbatim whatever that's from the current method. So we're going to say h and n over here, and then for the solution set, we're going to pass this reference only. So throughout the course of the recursive call in this particular tracing, there's only one single object for hash set that's being created, which is over here. We're only passing the reference over here, and then to begin with, for the current solution so far over here, we'll simply just give a new empty array list. You can say make an anonymous object, that'll be okay. New array list, integer, and like that. All right, that's it. So what you really want to think about beyond this session here is about call by value. How does the call by value work to ensure only one instance of hash set is being updated among recursive call? Right, that's some comments for you. All right. All right, let's now talk about how we program this. Okay, and the structure will be very similar. So we want to think about when h is less than 0, right? When and also else if h is equal to 0 over here, and also else when h is larger than 0. That will correspond to when h less than 0 is like a base case like this, meaning that the solution we have constructed so far is not a valid solution. So we simply discard the link. We simply discard the array list constructed so far. When height is equal to 0, in that case, that means the array list we have constructed so far should be added to the solution set. When h is larger than 0, for example, over here, that means we're going to make some recursive call, right? To use a loop to go for either choice number 1 or choice number 2, all the way up to choice number n, right? So that'll be the rationale. And when h is less than 0, we'll simply say do nothing. Since the solution constructed so far is not valid, do not add it to the set, because we have already gone beyond the top of the staircase, right? That's for this. Just leave it empty over here. And when it is equal to 0, that's a good sign. That means so far we have actually got solution constructed so far is valid for reaching to the top of the staircase. In that case, what we will do is whatever you have constructed so far can be added to the solution set, right? I'll go back to the tree in a moment. So we can say solution set dot add over here, solution so far. All right. So this one really corresponds to when we get to, let's say, this point over here. When we get to this point, the solution so far is this particular array list. And then we know that the height is equal to 0, meaning that this one here, 112, is guaranteed to be a valid solution for us to reach the top of the staircase. So we're going to add this array list into the global set. That's what we're doing. All right. That's good. So these are the two base cases. What about the recursive case? So now the recursive case, we want to make sure there's no interference. Make sure there is no interference of the solutions to be constructed over different branches, right? And how many branches do we have? It depends on how large n is. In the case where n is equal to 2, in that case, we want to make sure, for example, if you actually, let's say we're currently here, this is a solution so far. If you go for this branch, you want to make sure you don't really reuse the same list and add 1 to it, and also use the same list and add 2 to it. In that case, you will just get a list of 1, 2, 3. You simply get one list with 1, 1, 2. That's not the way to go. You want to make sure you create a new list in this case, and also create another new list in this case, and copy the contents over and add 1 or 2 into it separately. All right, that's something you want to think about as well. That's a technical detail you want to pay attention to. Over different branches. Okay, we're almost there, and then let's now, how do we create a new list? You can simply do array list, integer, and then we can say current solution. Right, current solution as opposed to a solution so far. Think about the current solution is going to extend the solution so far by the choice we are making. Okay, current solution is how do we create a brand new object? You can look into the API for array list. You can simply create an array list out of another array list, which is guaranteed to be a different list. Okay, and then you can leave out this part over here. The type, the compiler will take care of that. Solution so far over here. Okay, so that's the list, and then don't forget, we want to run a loop, right? I forgot to actually run a loop. Give me a moment. Let's say this. We need a loop over here. Integer I is from 1 all the way up to and including n, less than or equal to n, I plus plus. For every iteration, depending on the I value over here, so you can see I can be, in this case, I can be 1, I can be 2. When I is equal to 1, that means we're going to add 1 to the current solution, right? Let me paste it back. over here, that's the current solution, and make sure the current solution is extended with the current choice you're making, which will be the value of I. Right? Okay, we're going to put I over here. And then finally, we're going to make a recursive call. So we're going to say climb strategies helper over here. Let's put it here. And this part over here will be very similar to yesterday, right? Because we have chosen to take I steps. So that means the stair, what will be the remaining staircase to the climb? H minus I. And the number of steps you can take maximum will still be the same. And we are still using the same solution set throughout the recursive call by value. So the same. So it has the same value over here. And then the current solution, oh, guys, hopefully my voice is still okay, right? Okay. The current solution will be passed over here. All right. And that's it. That's the solution. You can see the structure over here for this recursive helper method is kind of similar to what we said yesterday for the simpler version. But now we have to make sure we create the set and also array list around the structure to make sure you can really keep track of what we have got so far, right? According to what we set over here in the diagram, right? You want to look at both, right? So let's now see how we can test it very quickly, right? And then we are done, right? I think for the tracing, it's going to be just like this for the tracing, right? So that's something I'll leave to you to really understand, study the code. Right, so you can go back to your E-class announcement from yesterday. I'll show to you. Remember that's the announcement I made back on Tuesday. And I gave you some starter tests over here. You can copy the second one over here. Okay, copy that. And if you go back to Eclipse, and then I'm going to paste it over here. Okay, so I guess I have to import the array, of course. And also I need to import the array list. I also, let me give me a moment. I need to import array list. I also need to import the hash set. There we go. All right. And let's now run it. All right. Green bar, right? Of course, this is only one test case. I would suggest if you really want to program your solution, let me give you a final tip over here. What you should do to go beyond this example over here. Okay, I'm done. I'll take a question in a moment if you got any. We got a few minutes to take a question if you got any. But let me suggest the exercise you should do. Okay. So exercises. Okay, so number one, you can definitely study my solution. And you can refer to the E-class announcement about how you should really study my solution. You want to make sure you study the detail and then try to do something irrelevant for a few hours and then come back to see if you can reproduce the solution to make sure you really understand what's going on. Number two, you can feel free to try alternative. If you want, right? Maybe you believe there might be a more efficient way to do things differently. In that case, you can feel free to try. And how can you double check the answer? You can actually try different inputs. For example, you can try maybe climb strategy. For example, you can try maybe for 10 and then 3. That's definitely a much larger set that will be returned. Okay, you can see what's returned by my solution. You can think about my solution as more like an oracle, right? Something that will always return the right value. What's returned by my version. And then compare against output by your version. If they actually agree with each other, so that means your solution should be okay. If not, then that means your solution may not be good enough. All right, that'll be my suggestion to really go beyond. But if you believe that you cannot really come up with anything else, yeah, that's okay. You can stick to mine. I think it's a very good case study about the two parts problem that we are doing this week, right? I think the climb itself is easier, but it's not that easy. You still need to understand how it works recursively. But definitely, this problem we are solving today is much more challenging. I think you definitely want to make sure you can also do this at some point soon. All right. Do you guys got any more questions? Anyone? If you feel yourself getting lost, that's okay. I think I really covered that as clearly as I can. The recording will be there. I think study the code, and then once you want another listen of my explanation, you can feel free to watch that. But I think hopefully you get a overall big picture. All right. All right. Any more questions?
I just had a quick question.
Yes.
So when we were doing group sum, we would only like back then the version we were working on would only return if it's possible, like true or false, if it's possible to get like that sum. Would it be possible to like adapt the solution to that and then return all the subsets that work to give you that sum?
John, can you say it again? I want to make sure I understood you properly.
Yep. So for a group sum, would it be possible to do some sort of solution like this to return all the sets, like subsets of that set were given,
Yep.
to like that add up to that sum, like return all the arrays that add up to that sum using a solution kind of like this?
So John, are you asking? You're talking about group sum, right? Am I correct? Your group sum.
Yeah, but now it wouldn't be. Yeah, you wouldn't.
So
return
you're
it,
talking
you would return
about
like
another way to do it is by first of all calculating all the subset or subsequences. Let's say subset. I know what you mean. You're basically calculating the power set of the original array, and then make sure you know the sum for each one of the member, each of the subset, and then filter out those that wouldn't hit the targets. Am I correct?
like not even that, just like so the way we did it here, we would like return true if it added to the sum, right? If like the all the numbers we went through added to that sum. But then if we like all the numbers we would look through, we add it into an array and then return it if it's true at the end. You know what I mean? Just like
I see what you mean.
to practice this.
Maybe
yeah.
John, maybe try to see if you can do it in Java. And then once you get it done, and then check coding back to make sure it passes all the test cases, and then reach out to me. We can take a look and discuss. We can even share the solution if you're willing to your classmate maybe next week if that's working. Would that be okay?
I understand. Thank you. Yeah.
Awesome. All right, guys. Any more questions? It's now 10, so I should really let you go. But if you have more questions, I'm willing to answer them briefly. I think so far we learned about 4 or 5 recursion problems. They are all non-trivial. I think if you really study them carefully, understand the details, understand the solution pattern, and the intuitive rationale behind, I'm pretty sure you will learn a lot about recursion. It's really important. It's really something that I cannot spend so much time in the lecture. Otherwise, it will take me 2 weeks or more than that to really cover them properly. But I think for the Q&A, we can have the luxury to do the extra problems. All right. Yeah, take advantage of what's being taught over here and then try to study them. I think it will definitely be beneficial to you ultimately for recursion. All right, guys. Thank you so much for coming. And then I will see you later. And you guys have a good day.